Web3, crypto. New shiny technology, right? Got some bad news for you. The 1970s called, they want their tech back. All right, a quick history lesson before we dive in too far. In 1976, Whitfield Diffie and Martin Hellman came up with an idea for a digital signature scheme, and we still use it today. What they proposed powers the technology today that we use for Web3 wallets. Using a private and public key pair, we can verify identity. So how does this work? Let's pretend we have two different people, Bob and Alice. Now, Alice wants to send a message to Bob, and she wants to make sure that Bob knows it's from her. How does she do that? Well, with digital signatures, the way this works is she sends the message, "Hi, Bob." Super simple. She sends that message, and she also signs it. When she signs it, she uses her private key. Now, a private key is something you don't share. It's something that's private. You keep that secret. If you're familiar with Web3 wallets, it's going to be the secret key that you never share with anyone. The common phrase is not your key, not your crypto. It's that key. That's your private key. You can use that key to sign a message. When that message is signed, you generate your signature. You can then pass the message and the signature to another party. This will ensure that you're the one who signed the message, because using your public key, which is your wallet address, you can verify the signature of that message. This is pretty cool. This allows us to do things like log in with a wallet. We can prove our identity using our wallet. We don't have to share any other information. We don't have to create a password. We don't have to share an email address. All we have to do is share our public wallet address, and that's it. So let's take a look at how to build this using SvelteKit, Ethers.js, and a Web3 wallet. Let's dive in. All right, so we'll start out with a basic Git repo here. And the first thing we're going to need to do is install SvelteKit, Tailwind, and Daisy UI. So SvelteKit is installed, npm create in the current directory. We'll install it as a skeleton project. We'll use TypeScript, ESLint, and Prettier. I'm not going to use Playwright or Vtest. Now we need to do npm install. Next, we'll go ahead and commit to Git. And finally, we'll run npm run dev. This will start up our server for us, so we make sure everything's working. All right, so we can see here that our SvelteKit is up and running. We've got our basics here. Let's take a quick tour of SvelteKit in case you're not familiar with it. I'll keep this brief if you are. We have our source directory here. Underneath source, we have our routes. Svelte uses plus and then page to determine what it is, and it's going to be route based. So if we want a different route, we'll need to add folders within our routes directory. We're going to install Tailwind and Daisy UI, which is a component library for Tailwind. Let's go ahead and do that now really quickly. Stop our server from running. We'll install Tailwind. We'll initialize the Tailwind config. You should notice it created a few things here. If we take a look at our SvelteConfig.js, we'll notice that it added a preprocess, and it also added that preprocess here to our preprocess. And finally, we'll need to go to Tailwind config and set up the content that we want to apply. We head to Tailwind config. Here in content, we'll replace this with the type of files that we'd like to apply to. And finally, the last thing we need to do is add the Tailwind directives to our CSS. That CSS is in source app.css. So source, new file, app.css. And here we'll add in our Tailwind directives, give it a save. And finally, we'll need to create a layout.svelte for our entire project. So underneath routes, we'll create another new file and plus layout.svelte. This will apply to all of the pages that come underneath this in the directory structure. We'll import our CSS, and then we have this slot here that will basically take everything that is in the page.svelte and apply it here. Give it a save, and we should be good to go. Let's run dev. You'll notice the formatting has changed completely on our SvelteKit page because we've stripped everything out and we haven't used Tailwind at all on this page. If we want to check and make sure everything is running smoothly, we can change our page.svelte to something that looks a bit more interesting. We'll give it a hello world using Tailwind, and that will give us our hello world underlined and in bold font. So cool, Tailwind's up and running. We're gonna use Daisy UI as well, just because it makes life really easy when it comes to creating components using Tailwind. To install Daisy UI, we'll need to stop our server one more time. Install Daisy UI. Once that's installed, within our Tailwind config, we'll need to add the Daisy UI plugin. And we should be up and running. All right, and to ensure that Daisy UI is working, we can now create a button with just a class of button, and we'll see here, it shows up nicely. All right, perfect. Everything's working. We can see our button here and we are ready to go. So we're going to build a couple of components in order to create this application. The first component we're going to build is a component to connect our Web3 wallet to the application. And then after that, we'll create another component for that local signing experience. It'll send a message that we will sign, and then we will be able to verify we are who we say we are with that signature. So let's get started. The first thing we'll need to do is create a couple of files, starting with that wallet connect. We can create a new file here in source, and we'll call it lib/wallet-connect.svelte. One thing to note, when you do lib/, you're creating the directory lib as well as the component itself. So we have our wallet connect component here. What does this need to look like? All right, so the first thing that we're going to want to do is create a button just to make sure our component is working. So we have our button here, attach wallet. Now, how do we get this onto our page? Let's head back to page.svelte. And here we can import it. We'll clean this up, and now we'll import our wallet connect from our library, and then we'll go ahead and implement that as well. Give it a save, and we can see now that we have our attach wallet button. Awesome. So we've got our component set up. What next? Let's go ahead and build out the functionality to actually connect our wallet. We'll head back into the component itself. So we'll do a few things. The first of which is we need to add a function to be called when we click this button. Just clicking on it, it does nothing. So we'll call that function connect wallet. We need to create that function. So inside of our script tag here, we'll go ahead and create a function called connect wallet as well. So now every time that we click on the attach wallet button, we'll run this function. So what does this function need? First, we need to import Ethers.js. So we'll do that. Now, we haven't installed Ethers.js, so let's go ahead and open up the terminal and do that now. Awesome, Ethers is installed. So now we can build out our function. There's a few things that we'll need to do. We'll walk through this really quickly. We'll have a provider getting the actual wallet from our window, from the browser itself. You'll notice that window.ethereum has a red line under it. Why is that? Well, it's because it doesn't exist on that. We're using TypeScript and we need to define things clearly. So let's go ahead and fix that error really quick. The way that we fix this is we're going to create a global TypeScript definition file. In our source, we'll say new file. We'll call it global.d.ts. So here we're going to pull in from MetaMask providers, and then we're going to declare globally for interface window that there is an Ethereum object. And the question mark says, if it's there, then this is the type that it is. So if we have a wallet, then it's this type. Now our TypeScript can know what's available. Let's head back to Wallet Connect. You'll notice that error has gone away now. The next step, once we have that provider, is to request the accounts from that provider. From there, we can get the signer. That's going to be the account that'll actually be doing the signing. The account itself will be that public address. And then we have chain ID if we need it. We probably won't need it for this example, but if we need it, we can know what chain the wallet's actually connected to currently. Cool, so we've got all this information. Where do we store it? I'd like to store it in a property called Web3 props. And again, I'm going to define that as a type of Web3 props. Now, we're using TypeScript. We need to define that type. Let's just go ahead and define it globally in our global definitions. So we have an interface that is the provider, the signer, the account, and the chain ID. Once we've got that defined, we'll give our global types a save. We'll head back, and now you can see that we can use Web3 props and pass in the signer, provider, chain ID, and account. Fantastic. So at this point, we've actually connected our application to our wallet. We've gotten all the information we need. So this button, attach wallet, we only actually need it if we don't have these values in Web3 props. So let's go ahead and put an if statement around that button so it doesn't show up unless we don't have that information. Cool. Let's give it a save and see if things work. So we'll click attach button and it disappears. Why did it disappear? That's because I've already connected to my local host before. You'll see here, if I look at my wallet, I have this connected option on here. Go ahead and click that and say disconnect. We'll reload the page. Now when we click attach wallets, we'll get the option to connect an account. I click next and connect, and that button disappears again. Cool, so we've got that done. Our wallet's connected. Now we need to build out what happens next, how to actually sign a message. So let's dive into that. We'll head to our lib folder, new file, call it local sign.svelte. The first thing that we'll need to do is set up a script. We're going to work through this by setting up the script first, talking through that, the logic of what's going to happen, and then actually implementing it on screen. So the first thing we do is we set up our script tag. Within our script, we'll need to import a couple of things. We'll need to import Ethers because we're going to be dealing with that wallet. And then we're importing Fly. It's a transition from Svelte. It just makes things look nice. There's a lot of look and feel niceties in this example. You don't really need those. The core of this example is what we're going to be building out here in this script. So the first thing we need to do is define a few values. Now, we'll use Web3 props again. That's going to be that object that contains everything about our wallet. Once we have those, we will also be using a nonce. A nonce is essentially just a one-time number. While we're generating a random number, and it may not be truly random, it's good enough for this purpose in that every time we have a signature, we want to pass a different value in. We want to have a different message be signed. That way we can ensure that there's no sort of like replay happening, where if I always ask you to say, "Hi Bob," like the example we talked about in the beginning, once I see your signed version of "Hi Bob," I could send that, and I'm not Alice. So we want to ensure that every time we're asking for a new message to be signed, that's where this random number comes in. It just changes things up so that we have a different value that's being signed every time. Once we have that established, next we need to have a place for that signature to be stored. We also have a valid Boolean value that we'll be using. We have the address of who's going to be doing the signing, and then we have a value of if it's signed or not that we're using to show different bits of this component. We then have a expected address that's a string, and we have a value for not your address so we can see what it looks like when we try to verify an address that's not the address that we're actually signing with. All right, so let's get in that first signing example. We'll create a function called sign. Again, we're going to re-update the nonce because we don't want people to know what it is before we're asking for them to sign it. So we'll create a new nonce, a new value, a new number. Then we'll go ahead and get that signature. How are we going to do that? We're going to use a Web3 props signer, so that's going to be the account that's actually signing the message, and we'll ask them to sign the message. We pass in a string, sign this one-time nonce, and we give them the nonce that we're going to have them sign as well. So they'll sign that entire message, that entire string. If you were using this example for actually logging people in, this would be a value that you would store in a database, for example. When I sign in, I would then generate a new string that I want to be signed the next time somebody tries to sign in, and that's what I'd be verifying. So this should happen each time you want a signature to occur. You generate a value and you store it. You wait for the signature to come back so that you can use the value that you asked them to store to verify. We set the signed value to true. That's going to enable us to go to the next step in this process, which is actually verifying. So what does verify look like? We need to get the address that signed the message. Using Ethers in the utils, there's a verify message function. If you know what the message was, you can get the public address of the person who signed it once you have the signed message, that signature. So we pass in the signature, we pass in our actual value. And again, here we're storing nonce locally, but this is where if you had multiple users, you get this value from someplace else, like a database, and you pass that in. Think of it like checking for a password. And then we can say, hey, is the expected address who we thought was going to be signing this, who actually signed this? That gives us our Boolean for our validation. And then finally, we're going to create one more function just to kind of reset everything so we can do this multiple times. It just basically zeroes out everything else. So it resets our nonce, our signature, the validity, the address, resets the account, and it resets signed. And that's it. So how do we actually implement this? Now, this part is going to be a little bit longer. And again, I'm going to go fast through it. All the code is available on GitHub if you'd like to look at it, because the interesting part here for what we're talking about is how to actually do the signing, get the signature, do the address verification. It's not so much the look and feel of the front end, but hey, we might as well make it look nice as we go. So the first thing we're going to do is we're going to create a card for actually creating that signature, or give the user the option of picking the expected address. If we want it to be their address, or if we want it to be that not your address value, so we can see what it looks like when you don't sign a valid value. So first thing we'll do is we'll create a div and a class, just kind of hold things in the middle. And then we've got a lot here. So let's start off by looking at this. We start off with, if it's not signed, we're going to show this information. Again, this is one of those things in Svelte that's just kind of nice, makes things easy. So if we haven't signed yet, we're going to show this. We have some transition stuff here where the cards come in, go out. That's where that fly comes from up above. We have an image from just a placeholder image. That's a random image, just again, to make things look a little nice. We have the user's public address. So we're getting that from that Web3 props back when we connected our wallet. When we integrate all these together, we'll need to pass that object around to our different components. We have the option to select the address we're expecting. And again, here we have multiple options. We have your address and not your address. That's going to be either the attached wallet's address or the not your address address. And then we have the button to actually sign, which will run that sign function up above. So that will run this function here, sign, and that will get us to the next step for verify. So if we save this, we've done a lot. Let's see what it actually looks like here. Give it a save, and we see nothing. That's because we haven't put it in our actual page component yet. So we have wallet connect, and also we'll need to go ahead and add local sign. Here we can use $lib, which is just a shortcut, make sure everything stays the same. And we'll need to pass in Web3 props. So first we're going to need to create Web3 props here in this page. Let's create the Web3 props here. And then we'll need to bind that to our wallet connect and our local sign. And we can see we're getting an error, and that's because we shouldn't show local sign unless we actually have that account. So we'll need to add a little bit of if logic around this. So we'll say if we don't have an account for our Web3 props, let's go ahead and show the wallet connect. Otherwise, we'll show our local sign. Cool. So now we have our attached wallet. We'll go ahead and attach our wallet. And once we've attached our wallet, we can see here that now we have our public address, right? And so if we head back to our local sign component, we can see where this is coming from. So we have your public address. So we have your public address. We have our account that we're getting from those Web3 props. So that is my wallet address that's connected. If we check the wallet itself, we can see that, hey, it ends in 85A9. Both of them do. And we have the address that we're expecting. So it could either be my address, or we could pick not my address. And then we click sign. And it'll ask us to actually sign a value. You can notice here we have our one-time nonce. If we cancel this and we click sign again, we can see that nonce has changed. So signing won't do anything just yet. We need to build a little bit more into this. Let's get to the second part here. So once we've got all this done, if we haven't signed, now we want to say, hey, what if we have signed? And there's a lot of stuff again. We're going to walk through it. So again, we have the same thing for the fly in, fly out, make things look nice in our transition. We have our random image. We have a little bit of description just to make sure that everybody understands what's happening here. Using the message and the signature, we can derive the address, the public key that signed the message. So we can get the message that was signed. We can get the signature. That's what we'll have here. So we have our signed message. We have our signature. And then we have the expected address. That's who we're expecting to have signed it. And we have the derived address. That's going to be what came back from verifying that. If the derived address is the same as the signed address, we're good, we're valid, and hey, you're who you say you are. If it's not, you're not who you say you are, and we shouldn't do anything further with you. Our verify signature will actually run that verification process and say, is it valid or not? And then we have our start over button to reset the entire process. So again, there's a lot of stuff in here with Daisy UI and Tailwinds. I'm kind of blazing through this. This code is available to you in the repo that you can find in the description below. So let's give this a save and see what the whole process looks like when we run a signature. So we'll give it a save and we're back here again. So we select our address. We'll pick my address this time, your address, and we'll click sign. It'll ask us to sign. We'll click sign. We can see here that this was the message that we signed, and we can see what the resulting signature looks like. If that's something that you're interested in, you can see what it looks like here. We can see based on deriving the public address of who signed that signature, given the input of the message itself, who we're expecting it to be. And then we can verify our signature. And hey, I signed it and I was expecting it to be me. So hey, we're good to go. If we start over really quick and we were to say not my address and we were to sign again, we can see here that you have the signature and the expected address. If we were to verify, the derived address doesn't match the expected address. Hey, something's wrong. The person we expected to sign this message didn't actually sign it. All right, so that's it, the entire tutorial. We've created a public private key signature process to verify users. From here, you can go on to build a database that stores this information so that you can verify users for your platform. If you'd like to see more like this, let me know in the comments down below. Give it a like and subscribe. I look forward to catching you in the next one.